Welcome to the video on substitution method. This is the first video on that. So last time we looked at solving systems of equations and we looked at the three cases that could happen. One was where they meet. This system here has a solution. This solution right there is -2 and 3. We call this situation consistent. Consistent. And sometimes they don't meet. These two lines are parallel. And so this situation is called inconsistent. Or we could also say no solution. Either one works. And the third situation is over here. What you're looking at there actually is two lines. You can't see them, but there's a blue line underneath it. This is called dependent. So if you think of solving a system as finding where they cross or two lines cross or meet, clearly this one here meets everywhere. So it has an infinite number of solutions. Now, graphical methods are good to conceptually understand what's going on. However, you need to know how to do this algebraically, because as you saw last time in the last video, it's very hard to draw these lines to cross precisely and nicely. So the first algebraic technique we'll look at is called the substitution method. Substitution method. Okay. And we'll do this with an example, and I'll write the steps as we go along. So solve. All right, write the two equations in two colors so you can sort of see where the pieces go as the pieces move around. We'll also number these equations 1, and the second one is 3x plus y equals to -3. That's 2. Okay. So the substitution method says, the steps says, choose one of, so the first one, choose one of the equations, it doesn't matter which one, choose one equation and solve it for one of the variables. So you have a choice of either equation, you pick one and you solve it for either the x or the y, it doesn't matter again which one. You're just going to do it based on what's easy. So for example, when I look at number 1, I can easily see that it's easy to solve for x. When I look at number 2, I can see that it's easy to solve for y. Now it doesn't matter which one I do, but for the sake of this example, I'm going to choose one and solve for x. So in this case, I'm going to choose one and solve for x. So that's my first step. So yeah, take my first equation, and I'm going to minus a 2y from both sides, and I get x equals 4 minus 2y. Now the second step is to substitute, and this is where the method gets its name, substitute your result for that variable in the other equation. So you're going to take so here's the other equation, the second equation in our case, and what we are being told to do is you're going to take this result and substitute it in for x in that equation. So then you get 3, and instead of the x you have 4 minus 2y, make sure you use parentheses, plus y equals -3. Distribute 12 minus 6y plus y equals -3. So simplify on the left side and then solve for the y. Minus 15, divide both sides by minus 5. Okay, negative over negative is positive. 15 divided by 5 is 3. Just to back up a minute now, what we have found is the y piece of where they cross. Now this dot is on both lines, so I can use either of those lines to find the x piece of that dot. Just simply take the 3, plug it into either one, doesn't matter which one, and whichever is easier for you, and then find the x piece. So substituting for the steps, so this part is step 2, so this is step 2, this part is step 1, right? This is step 3. So step 3 is solve. Step 4, the remaining variable. Okay, and then step 4, which we haven't seen yet, is find the second value using either equation. Okay, so I'm going to now take my y equals 3, and I can use any one of these equations to find the x. So in fact, the easiest thing to do would be to use that right there. So just to keep everything on the screen, I'm going to scoot over here. So x equals 4 minus 2y, and instead of y, I'm going to put in 3 from there, and then I get 4 minus 6, which is minus 2. And so my result is minus 2 and 3. So if you go back up here, we sort of see that, minus 2 and 3. That's where they cross. Okay. Now, I've got the same answer if instead of solving for x on that first step, I had solved for y from the second equation. Now, if I had done that, then I would have taken that result and put it in for y in that first equation. It doesn't matter which one you solve for, as long as you solve for one of the two equations for one of the letters, and then substitute into the other. Whichever one is easy for you to do, you do it. Okay. All right, we'll take a look at more examples coming up in future videos.